video today is going to be on adding and subtracting fractions, which is going to be a little bit different than multiplying and dividing, totally different operations, and then we're going to get into a complex fraction at the end. So when we are adding, subtracting fractions, you want to think about the basics. Just remember back to the most simple thing that you can think of. Let's say 1/3 and 1/2. You know that you can't just add 1/3 and 1/2 because with a fraction you need a common denominator. So I think about those two denominators. What would be the common denominator? 6. So I'd have to multiply top and bottom by 2. Oops. To make that a 6, then I'd have to multiply by a 3 over here. So that would give me 2/6 plus 3/6, which would be 5/6. And the same is going to be true with rational expressions. You have to get a common denominator. The key with adding and subtracting fractions is to get that common denominator. So when we look at number 1, we're going to start off easy because look, you already have a common denominator. You don't have to do that work. So we see, but this one is a little extra. We are subtracting. So when you put these pieces together, when you add your fractions, see how we added the numerators and the denominator stayed the same? So when I put these together, I'm going to do 4 minus 3x plus 2 over the denominator of x plus 2. I'm subtracting that entire expression. So a lot of times what I like to do from the beginning is change the subtraction to an addition and then distribute that negative so that I don't forget later. But you don't have to do that. You can distribute in the next step. So that gives us 4 minus 3x plus 2. So we have our x term first, which is a negative 3x. 4 minus 2 is going to leave us with a positive 2 all over x plus 2. So just some practice on adding our fractions when we already have the common denominator. Now number 2 is a little bit harder because I don't have a common denominator yet. I need to get a common denominator. Just like I did with 1/3 and 1/2, I need to get that common denominator of a 6. So we look here, I'm going to factor. So I look at the bottom and I see that I want to multiply to 32 and I want to add to 12. The two numbers that multiply to 32 and add to 12 are 8 and 4. I'm not going to factor the top. Factor cancel is what we do when we're multiplying and dividing. When we are adding, subtracting, it's all about getting that common denominator. Okay, so now that I have factored, I see that this denominator has an x plus 8 and an x plus 4. This denominator only has an x plus 8. So when you get a common denominator, it has to take into account all of the pieces from all the denominators from all of your pieces. I only have 2 pieces here, and they already share the x plus 8. So what I'm missing over here is the x plus 4. Just like when I got a common denominator with my numbers, I had to multiply the top and the bottom so that I'm not changing the value of the fraction. So now I've got x squared plus x plus 3. I'm not changing that first fraction because it had everything already that I needed. Our second fraction, we're going to multiply this out. So we factor the denominator so that we can see the pieces, the rational expressions, and that we can figure out what we have and what we still need. In the numerators, we're going to multiply our pieces out so that we can combine like terms. So that becomes 3x squared plus 12x. And now I have that x plus 8 and x plus 4 common denominator. See how we have the common denominator now? X plus 8 and x plus 4. When you have the common denominator, we're going to push that together into one fraction. So we're going to combine the numerators, and remember when we add, the denominator does not change. So this stays as x plus 8 and x plus 4. And the numerators, again, we want everything multiplied out so that we can combine like terms. I have 1x squared and 3x squared. That becomes 4x squared. X plus 12, that's 13x plus 3. So one of the hard things about when we are adding, subtracting fractions is multiplication, division, it was nice and easy. Factor, cancel, it was one process. When we're adding, subtracting, there's several different things that we have to be careful about. The first thing we do is we factor the denominator so that I can see what my common denominator is going to be. I have to multiply out the numerators so that I can combine them together. But now that I am into one fraction, if you remember the multiplication division day, when you have one fraction, you do have to check to see if anything can cancel in that fraction. So after multiplying everything out, I had to go back into factored form in the numerator. The numerator is factorable by Batman. So we have 4x plus 1 and x plus 3 all over x plus 8 and x plus 4. We have to factor it back out in the end once we've combined to see if anything does do a factor cancel. And we don't have anything that cancels, so we're going to leave it like this. But we do have to factor it in case something were to cancel out. Because if you didn't cancel something, it wouldn't be in simplest form. Generally, with adding, subtracting, the hardest part is getting that common denominator. So I'm looking at the denominators. I see that I have a 6 and I have a 6. Okay, so that's good. The two denominators have that in common. But our first piece has an x minus 2, and our second piece has just an x. Remember that x minus 2 is an entire expression that needs to stay together. So I'm not going to break this apart and say, oh, this already has an x and this has an x. All I need is a minus 2. No, this is a piece and this is a piece. So the first one is missing the x. And our second piece here is missing the x minus 2. So the common denominator is the 6 and the x minus 2. So we need to make sure that our pieces have that. We multiply our numerator, so that's 7x. We are subtracting on the bottom here. Again, we have our common denominator, 6x, x minus 2. In the numerator, we have a binomial times a binomial. So x times x, x squared. X times a negative 2 is a negative 2x, and this gives us a positive 3x. So 3 minus 2 gives us a positive 1x. 3 minus 2 is a negative 6. And I multiplied, distributed out, or FOILed the x plus 3 and the x minus 2. Now that we are here with our common denominator, we're going to combine our numerators together. Remember, we have subtraction. So I change this to a plus and I distribute my negative. You've got to make sure that when you're subtracting, you distribute the negative to everything in that term. So on the top, we end up with a negative x squared, a positive 7 and a negative 1. That gives me a positive 6x and a positive 6. And then when we add our fractions, we combine the numerators and the denominator does not change. We would check, we would pull out that negative, which would give me a positive 1x squared, a negative 6, and a negative 6. But that's not factorable, so I can go ahead and leave it like this, or you can show pulling out the negative. All right, our next one, x plus 1, x plus 2, nothing factorable there. When I look at the second piece, our denominator, we're multiplying to 6 and adding to 5. That's 3 and 2. We look at our denominators. This one is x plus 2, this is x plus 2, and x plus 3. So the first one is missing this x plus 3. I'm going to multiply top and bottom to get that common denominator. And we're going to FOIL out the numerator. X times x is going to give us x squared. That's 1x and 3x, so that becomes 4x. 3 times 1 gives us 3. And now we have that common denominator of x plus 3 and x plus 2. Here, we aren't changing the second piece because we already had everything. So I'm going to change that minus to a plus and distribute my negative. So this is a negative 7x and a negative 13. Once we have that common denominator, we can go ahead and combine our numerators together. That gives us x squared. 4 minus 7 is a negative 3x. 3 minus 13 is a negative 10. All over x plus 3 and x plus 2. And if you remember, the hard part about adding and subtracting is you're constantly factoring some pieces, multiplying out other pieces, and you're going back and forth between those. Just remember that the denominator needs to be factored to find the common denominator. You multiply out the numerator so that you can combine like terms. But once you have one fraction, once you've actually added or subtracted the fractions together, it's about simplifying that fraction. So I need to factor this. If I'm multiplying to a negative 10 and adding to a negative 3, that's a negative 5 and a positive 2. And when I factor those pieces out, I see that I can cancel x plus 2 and x plus 2. So my final answer is x minus 5 and x plus 3. Alright, so next we have a complex fraction coming up, and this is where we really need to pay attention. A complex fraction is a fraction that contains a fraction in its numerator and or denominator. So it's a fraction within a fraction. What I like to do with complex fractions is to really separate the numerator and the denominator. What we want to do is we want to end up with one fraction on top and one fraction on the bottom. This one isn't actually that bad because I already have only one fraction in the numerator, so I don't have to do anything to that numerator. But on the denominator, I see that this is 1 over x plus 2, and this is 2 over x. I need to get that common denominator. This piece is missing the x plus 2. This piece is missing the x. So the first one, 1 times x is just x over x plus 2. The second piece, we distribute the 2. So on top, that's 2x plus 4. On the bottom, the x plus 2. Because remember, we always multiply out the numerators so that we can combine like terms. So on the bottom, we had two fractions. We created that common denominator so that I can add those fractions together. Again, we're kind of ignoring the top right now because there's really nothing that we need to do at the moment. So on the bottom, we have the common denominator. We have 1x and 2x. That gives us 3x plus 4 all over x plus 2. Okay, so again, step number 1 is to get it so that you have one fraction in the numerator and one fraction in the denominator. We started off with two fractions in the denominator, so we had to combine those together. We were adding our fractions. Now that I have one fraction on top and one fraction on the bottom, this now becomes a simplification problem. And the key to remember is that this symbol right here, this fraction symbol, means division. So I'm going to start off by rewriting it. 2 over x plus 2 divided by 3x plus 4 over x times x plus 2. So instead of writing it as a fraction, I wrote it as a division problem. Now it becomes a multiplication division problem, and we know that when dividing, we don't divide, we multiply by the reciprocal. So that becomes 2 over x plus 2. We do the reciprocal, so we put x plus 2 on top, 3x plus 4 on the bottom. and we cancel. We've got an x plus 2 and an x plus 2. So on top, 2 times x leaves us with a 2x. On the bottom, we have 3x plus 4. Nothing else can factor out, so we are finished there. Okay, so just remember, goal is to get to one fraction on top, one fraction on the bottom, and then rewrite it into a multiplication division problem. All right, we are all set.